Good day once again, my name is Graphics. Today we want to calculate for the total current and the total resistance in this circuit. So we are going to be analyzing the circuit now. If you look at this circuit using your series and parallel network method to analyze the circuit, we realize that this 2 ohm resistor and the 6 ohm resistor are in series because of the same current is flowing through them. Because whenever analyzing the circuit, you start analyzing it from what? From the back to calculate the total resistance. If you look at it very well, these two are in what? In series. So if I add these two resistance, I'll be having what? 8 resistance. 8 ohms, right? So this is what I'll be having. So I represent this with RA because I still have other resistors here. So I represent these two just with RA. So I'm adding 6 and 2 because they're in series, just one string of wire connecting both of them together. So the same current is passing through them. So that is 8 ohm. So I'm going to withdraw. Now I have withdrawn this, and the 8 ohms will be here. I'll call it my RA equals to what? My 8 ohms. I can either put this here or here. Any is the same thing. Any of this place is the same thing. Right? Now if you look at this very well, we're still moving to the next category here. Now, this we know is 12 ohms here from the actual question. This we know is 6 ohms here. This we know is 2 ohms here. This we know is now these two you see is in parallel. Why is it in parallel? Because at this junction here, current will flow in this manner, right? So since they're experiencing two different currents flowing through them, you see both of them are in parallel. So this 12 ohm resistor and this 8 ohm resistor are in parallel. We represent this using ROB. Now look at my ROB, these two are in parallel, so I'll say my 12 is parallel with what? My 8, right? My 12 ohm parallel with my 8 ohm. So I'm going to write it as saying that the 12 multiplied by the 8 all over what? The 12 plus the 8, right? And this will give us 12 times 8, so we have 96 all over what? 20. So divided by 20, I'll be having 4.8. So this will give us 4.8 ohms, right? Now I'm going to redraw this again to show what has happened. Now this is what you are going to be having. The ROB will be 4.8 ohms, which we just calculated here, and this is what we'll be having. Now what do you notice? These 2 and this 4.8 are in series. How good? They are in series because the same current will flow through this, connecting this, right? So I'm going to write that I'll call it to be ROC. Why I'm using ROC? Because there are still resistors still remaining, so I'll be representing them with different values, different alphabets, and that will be the 2 plus what? 4.8, and that will be giving me 6.8 what? 6.8 ohms, right? That is the ROC. And now I'm going to withdraw this. If I withdraw this, I'll withdraw it connecting the two together. So in withdrawing it, this is what we're having. This guys in series is what we're having is 6.8. Either you write it here or you write it here. It's the same thing since they're on the same line, right? Now if you look at it very well now, these two is in what? Is in parallel. In fact, 1, 2, 3 are all in parallel. Are we good now? 1, 2, 3 are all in parallel because the current that reaches here that is being supplied between these 3 resistors. Is that taken? So I'm going to solve them now. In doing that, I will have this way. So for better understanding, to avoid confusion, I can easily see here should be equals to what? R1, here should be R2, and here should be what? R3, just for better understanding. Because we have 2 6 here, I don't want to bring confusion. So I'm going to say my RD, right? I can easily call this my RD, because we need my RD is equals to, this is my RD here, this is my RC, sorry, this is my RC here. So I can say my RD is equals to, I'll say R3, R2, RC. I'll multiply all of them together, all over. I'll take them 2 at a time, right? So it will be R3, R2 plus R3, RC plus R2, RC. You might put them anyhow, but they must not repeat each other because 3 of them are in parallel. Now in doing that, I will now have this to be giving us my R3 here is 6 times R2 is 6 again, multiplied by what? 6.8 all over R3 R2 will give me 6 times 6 plus R3 RC will give me what? 6 times 6.8. Then R2 RC will give me 6 times 6.8. Right? So this will now give me 6 times 6 times 6.8 is 244.8 all over 6 times 6 is 36 plus 6 times 6.8 is 40.8 plus 40.8. All will be giving me this 244.8 all over 40.8 plus 40.8. That will give me 81.6 plus 36. That will give me 117.6. Now if you divide this, we're having 2.08 ohms, right? So that will be our RD. Now we are going to redraw to see what we are going to be having. Now in redrawing this down here, we say these 3 of them are in series, are in parallel. So we now got these 3 to become 1, which is 2.08, and we'll replace it here. Now if you look at this now, when the current is being supplied from this and gets to this node here, right, split it into these 2 directions. So it means that what? Since they are experiencing 2 different currents, both of them are in what? Are in parallel, right? So I'm going to put that my RE is equals to what? 2 times 2.08 all over what? 2 plus 2.08, because RE is equals to what? 2 parallel to what? 2.08. All good? So they are parallel. So from here, if I multiply 2 times 2.08 will be 4.16 all over 4.08. So we'll be having 1.020. 1.020, that will be my RE, right? So you're doing it that way. Now what am I having remaining here? I want to redraw this now because I've made this to resistor 1, which is 1.08. So if I redraw this, I'll be having this. Now these 2 you see now are now in series. because these two, you see, has been made to be one, which is this, right? So we have this in series. So you are going to say now, you will now use the word arrow equivalent. That is, arrow equivalent is what you use now, and that will be 3 plus what? 1.020 ohms. Now I'm using arrow equivalent because of what? Aside from these two resistors, there is no any other resistor in the circuit anymore. So this will now give me 4.020 ohms, right? So I'll put this here, they are in what? They are in series, right? Now I've gotten our total resistance, which is our resistance equivalent here. Now I want to know what the total current in the circuit is, and this will be, according to Ohm's law, we know that V is equals to what? IR. So my I is equals to what? V all over R. So we're talking about my V total, my R total. I'll give you my I total. So my V total given this is what? 100 volts. 100 over what? My R total, which is what? 4.020. 4.020. So we're going to be having, to give us 24.875, which is approximately 24.88 ampere. So that will be my answer here. So if you find this video useful, don't forget to click on the subscribe button. Thanks for watching.